Hello, good morning students. Today we are going to discuss about the characteristics of scalar vectors. We have seen already scalar vector means what. So how we can define the scalar vectors if two vectors are given to us. So if two vectors are given to us like that A and B. So see, if two vectors are here, that is vector A and vector B, and the angle inclination between these two vectors is supposed to be theta. So theta is the angle inclination. So what about its scalar vector? Or we can say dot products. So this the dot product of this given vectors are vector A dot vector B, vector A dot vector B. Okay, vector A dot vector B is equal to AB cos theta. Okay, so we have seen in our previous videos all these things we are already seen. It means how we can take here dot product of given two vectors, that is vector A dot vector B is equal to AB cos theta. Okay, today we have to discuss about the characteristics of scalar vectors or dot products, we can say. Scalar products, or we can say dot products. So this is the scalar product, or we can say dot products. So we have seen already three characteristics of these dot products. Okay, so today we have to discuss about the remaining characteristics. Which characteristics are there which is necessary for dot products, or we can say scalar products. So our fourth characteristics is it obeys distributive law. It obeys a distributive law of multiplication. Distributive law of multiplication. If vector A, B and C are vectors, if vector A, vector B and vector C are given vectors, then we can write vector A dot vector B plus vector C in bracket. So how we can write? So vector A multiplied by vector B means vector A vector B plus vector A vector C. So this is the distributive law of multiplication. Vector A dot vector B plus vector A dot vector C. So this dot product obeys this distributive law. So this is the distributive law of multiplication, that is vector A dot in bracket vector B plus vector C. Then we can write vector A dot vector B plus vector A dot vector C. Now next characteristics, that is characteristics number 5. The dot product of vector with itself. The dot product of vector with itself is equal to square of its magnitude. Square of its magnitude. The the dot product of vector with itself is equal to square of its magnitude. So suppose we are taking one vector is here. Suppose this vector is a vector, and we have to take here a dot product of this vector with itself. It means there is only one vector, so therefore we can say angle inclination should be equal to 0. So therefore theta is equal to 0 because there is no angle inclination, or there is no another vector to form angle inclination. So therefore due to single vector we are considering angle inclination is equal to 0. So if theta is equal to 0, then cos 0 should be equal to 1. Okay. Now what is the dot product of this vector A? Vector A dot vector A is equal to, how we can write the dot product of this given vector? Vector A dot vector A means AA cos theta. AA cos theta means what? AA. So AA means what? The magnitudes of vector A and vector A. So AA cos theta, that is cos theta means what? 0. So we can put here the value of cos 0, it is 1. A into A we can write A square. So A square represents the square of its magnitude. So you should remember here, if the dot product is given and that dot product is of a vector with itself, so at that time whatever is the dot product of vector with itself, then it is exactly equal to square of its magnitude. So this is important characteristics. Whenever dot product is there of a vector with itself, so it is definitely it is equal to square of its magnitude. Okay, so such characteristics are very important. Now let us discuss about the next characteristics, that is characteristics number 6. So next characteristics is the dot product of the dot product of vectors, the dot products of vector two mutually perpendicular vectors, two mutually perpendicular vectors, the dot product of two mutually perpendicular vectors is exactly equal to 0, is equal to 0. So see, if the two vectors are, they are mutually perpendicular, means suppose these two vectors are there, vector A and vector B, and they are perpendicular to each other like this. So what will be the dot product of these two vectors if those vectors are perpendicular to each other? So for that purpose, draw one diagram. So here two vectors are there, so vector A and vector B, and the angle inclination between these two vectors is exactly equal to 90 degree, because we are considering these two vectors, they are mutually perpendicular to each other. So that's why theta is equal to 90. If theta is equal to 90, then cos 90 is equal to what? If theta is equal to 90, then cos 90 is exactly equal to 0. We know the value of cos 90, that is 0. So two vectors are here, that is vector A dot vector B is equal to, write down first of all the product of their magnitudes, that is the magnitude of vector A is A and the magnitude of vector B is B. So AB cos theta is the dot product of this two vectors, vector A and vector B, is equal to vector A B cos, instead of theta just we have to put 90 because both vectors are perpendicular to each other, so that's why the angle inclination between these two vectors, that is 90 degree, but we know the value of cos 90, it is 0. So that's why we can put here AB into 0, and AB into 0 means what? 0. So see here, you should be memorized when two vectors are perpendicular to each other. Now in this case, what is the dot product of these two vectors if these two vectors are mutually perpendicular to each other? So what is the dot product of these two vectors if they are right angle to each other? So definitely it will be 0. So this is the proof of that characteristics. If the two vectors they are mutually perpendicular to each other, then its dot product is equal to 0. Next characteristics, if the dot product is equal to next characteristics is the dot product is equal to product of their dot product is equal to the product of their magnitudes, products of their magnitudes, then two vectors then two vectors are collinear vectors. Then two vectors are collinear vectors. Collinear vectors means what? They must be parallel or anti-parallel to each other. Okay, what is the meaning of these collinear vectors? We have seen already in our theoretical concept, that is collinear vectors means they are either parallel to each other, we can say like this, or they can be anti-parallel to each other. Okay, so if two vectors are parallel or anti-parallel, then what about its dot product? So let us we consider, first of all we consider two vectors are parallel to each other here. So in first case, if two vectors we are taking here parallel to each other, that is vector A and vector B, and theta angle inclination between them is equal to 0 because two vectors are here parallel to each other. Now how we can take the dot product of these given vectors, that is vector A dot vector B is exactly equal to, what is the dot product of these two vectors? AB cos theta. Theta is equal to 0, so that's why AB cos, instead of theta write down here 0 cos 0, therefore AB cos 0, the value of cos 0 is 1, so therefore our dot product is vector A dot vector B is exactly equal to AB. AB stands for what? A means what? Magnitude of vector A, and B means what? Magnitude of vector B. So therefore the dot product of vector A and vector B which are parallel to each other, so then its dot product will be the product of its magnitude. See here, AB, what indicates AB? AB indicates that is the product of two vectors. The products of magnitudes of vector, because AB are the magnitudes of vector A and vector B. So see here, one word is very important, that is collinear. So collinear vectors represent the vectors should be parallel to each other, or we can say anti-parallel to each other. Okay, so this is the first case. Now let us discuss about the second case, when the two vectors are anti-parallel to each other. So in second case, draw the two vectors. They must be anti-parallel to each other, that is vector A and vector B. See here, anti-parallel means what? The direction of two vectors must be opposite to each other. Suppose we are taking two vectors and they are right angle to each other. It means we can say that the angle inclination in between these two vectors is equal to 90. So if we increases the angle inclination between these two vectors like this, greater than 90, greater than 90, greater than 90, up to this point. So it means what? These two vectors, they are directed opposite to each other. Okay, and what about the angle inclination in between these two vectors? This one is 90 and this one is 90. Okay, so 90 plus 90, 180. So you should remember, where two vectors are anti-parallel to each other, then the angle inclination between these two vectors must be equal to 180 degree. Okay, why we are taking there 180 degree? Because 180 degree means what? They are anti-parallel to each other. Our characteristics is related to collinear vectors, and collinear vectors, what happened actually in collinear vectors, though means in this case two vectors must be parallel to each other, either anti-parallel to each other, parallel to each other, or we can say anti-parallel to each other. If they are parallel to each other, then theta is equal to 0. If they are anti-parallel to each other, then theta is equal to 180 degrees. So you should remember this, or you can memorize these things. Now let us take the dot product of these given two vectors, that is vector A and vector B. So vector A dot vector B, that is vector A dot vector B is equal to AB cos theta. And what is theta? Theta is given, that is 180 degrees. So we can write here cos 180. AB cos 180. Cos 180. What is the value of cos 180? The value of cos 180 is equal to minus 1. The value of cos 180 is always minus 1. So we can put here, instead of cos 180, that is 1 minus 1. And if minus 1 is there, then the product of this AB minus 1 is equal to minus AB. So this is the dot product of two vectors, vector A and vector B, if they are anti-parallel to each other. Now concentrate on the answers. Vector A dot vector B is equal to AB. Vector A dot vector B is equal to minus AB. If they are parallel to each other, then the dot product of these two vectors must be equal to the product of its magnitude. So AB represents here the magnitude of two vectors. Here also AB represents the magnitude of two vectors. So we can say it is exactly equal to product of their magnitudes. Okay. So why here minus sign is? Because they are anti-parallel to each other. So that's why minus sign is there. But whenever the dot product of two vectors are there, so the dot product of two vectors, those vectors, they are collinear vectors. So such vectors may be parallel or anti-parallel. So such collinear vectors, the dot product of that collinear vectors must be equal to the products of their magnitude only. Okay, so we will discuss tomorrow, that is a cross product, or we can say vector products. Okay, so till then, thank you.